Imagine a scenario where a cat could be simultaneously alive and dead, held in a bizarre, indeterminate state. This thought experiment has captivated minds for decades, becoming one of the most iconic images in quantum mechanics. No, Schrödinger's cat was never a real experiment in the sense of being physically performed in a laboratory. It was a profound thought experiment, or Gedankenexperiment, devised by Erwin Schrödinger in 1935. Its primary purpose was to highlight the paradoxical implications of quantum superposition when applied to macroscopic systems. Schrödinger introduced this scenario as a critique of the Copenhagen interpretation of quantum mechanics, specifically its implications for quantum measurement. He wanted to demonstrate the apparent absurdity of extending the concept of superposition, where a quantum particle can exist in multiple states simultaneously, to everyday objects. The setup involved a cat inside a sealed box with a vial of poison, a Geiger counter, and a tiny bit of radioactive material. The core idea was that if a single quantum event, like the decay of a radioactive atom, determines the cat's fate, then the cat itself would enter a superposition of being both alive and dead until the box was opened and observation occurred. Understanding this thought experiment is crucial for grasping the measurement problem in quantum mechanics. It teaches us that quantum rules, while accurate for particles, lead to counterintuitive outcomes when extrapolated to the classical world without careful consideration. The cat serves as a vivid illustration of how different interpretations of quantum mechanics grapple with the transition from quantum probabilities to definite classical realities upon measurement. This famous feline has become more than just a theoretical tool. It is a cultural touchstone that helps explain complex quantum concepts without needing specialized equipment. It encourages us to ponder the very nature of reality and observation at its most fundamental level. Ultimately, Schrödinger's cat clarifies that the act of measurement is not a passive observation but an active interaction that causes a quantum system to settle into a definite state. It powerfully underscores the difference between the probabilistic quantum world and our deterministic classical experience, guiding our understanding of how quantum phenomena bridge to everyday existence.
If quantum tech fascinates you, like, subscribe, and keep exploring with us.